Selamun alaikum. I hope you are well and uh, good health, in good health. Uh, okay, how are you? Alaikum assalam. Okay, this is another session with only 4 students. Uh, that's good. Uh, okay. Uh, we can launch this lecture now. In the previous session, I talk about the replication. I introduced the replication, the definition. The replication is an important challenge in database, in distributed database, and uh, some methods. Some methods are introduced up to now for replication. Uh, okay, I'm going to talk about them. In the previous session, I say you that uh, one algorithm, one method for replication is single leader. Yes, single leader is one of popular algorithms uh, for replication. For managing the replication change. Okay, in these techniques, there is one leader and some followers. The leader uh, receive all requests or write requests from the uh, users, from clients, and the leader is responsible to manage uh, the right queries. Usually, the leader provide replication stream or data change. This is a file which consists of uh, some information, some fields, some data. For example, this in this figure, we can see the leader received the write request from the user 1234. Uh, this user wants to configure new profile picture. Okay, the update query is sent to the leader. Uh, Alaikum assalam, Zia. Uh, okay, this query is update users table, set picture set picture URL, me dash new dot jpg. Okay, this is the new picture from the of user 1234. Uh, okay, and this uh, we know in this technique there is one leader. The leader receive all change requests or query change query or update query. I can say update query, insert query, some query that wants to change the data. Okay, and the leader create this data change or replication stream consists of table users, primary key 1234. This is the ID of user. and the column picture URL. The old value is b-old.jpg, and the new value is b-new.jpg, and this is the transaction ID to specify. This is a unique ID for each transaction. The replication streams sends to all follower replica. Okay, so after some seconds, some moments, all replica, all follower replica uh, update is on, data is on recurs, and okay, so the clients can send the read query to all followers or leaders, and the read query can be processed by any of follower replica or reader replica. Okay, so the data, the information of all replica updated after some moments, and okay, we know the all replica must should have the same data. It's called consistency, and okay, the read query can be sent to any of follower. Okay, it's called leader base replication or master slave replication. After that, I introduced a synchronization versus synchronized versus asynchronized replication. In this figure, you can find the difference between the synchronous follower and asynchronous follower, because the follower 1 is synchronous and the follower 2 is asynchronous. Okay, synchronous follower before uh, uh, confirm any update query from any user, the synchronous follower should get the latest information from the leader and confirm that they this follower update its own data, and after confirm the leader can send the acknowledge the okay or acknowledge to the user. But asynchronous follower can update its uh, data after confirm the client request. Okay, so you can see in this figure the synchronous follower can increase the time of acknowledge uh, for for change requests, but the follower to which is asynchronous. This follower uh, does not increase uh, uh, the acknowledgement time, but uh, it's possible that in some moment, in some second, or sometime more than a second, for some minute, uh, the follower 2 use the uh, unupdated information, unupdated data. Okay, it can be cause some problem because the clients wants to use the latest information, not uh, before that. Okay, in this figure, you can see that the the update query is sent from the user 1234 to the leader before confirm the request, send the data change, the data stream to the synchronous follower, and wait for confirmation. Okay. After receiving the confirmation from the follower, for follower one or synchronous follower, the leader can send the acknowledgement message to the user 1234. The OK message to the 1234. Okay, so we know that the data of a leader and synchronous follower, uh, I can say in another sentence, the leader uh, used the same, the synchronous follower used the same data which are stored in leader. But also in this figure, you can see the asynchronous follower get the latest information after the client, after the confirmation that is sent to the user. Okay, so uh, okay, so uh, this time this time is the time that uh, the asynchronous follower uh, and leader okay, this time the asynchronous follower and leader follower use the different data. Okay. Synchronous replication. The followers is for synchronous replication. Okay, I'm going to talk about the synchronous followers that use synchronous replication. The follower is guaranteed to have up-to-date copy of data. Okay, and we know that the synchronous replica is consistent with the leader. And the leader must block all right, and wait for the other replica, for the other synchronous replica. Okay, so the leader must wait to receive the acknowledgement from the all replica. But we know that if any one node, if any one node outage, okay, for example, the connection between the node can be cut off from the other nodes, or sometime the node can be crashed. Okay, so any one node outage would cause the whole system to a halt. Cause the whole system to the halt. So in practice, synchronous and asynchronous replication used together, which is called semi-synchronous. Okay, what's mean? Uh, what suggested method is to use some replica, some synchronous replica and some asynchronous replica for a system, for a distributed systems. Okay, so sometimes it is called a semi-synchronous. Or leader-based replication is configured to be completely asynchronous. Uh, uh, with if we use asynchronous follower, it's possible to violate durability, uh, the leader can continue processing, right? Okay, the leader can continue processing every query request, every write query request we send from the leader, from the clients to the leader. The leader can continue processing, right? But this can violate durability. Okay. Any question about the asynchronous follower or asynchronous follower? Do you have any question? Okay. Can you hear me? Can you hear me? Hello? Okay, okay. Safa asked, is it a synchronous or asynchronous use diagram? Uh, the follower one is synchronous and follower two is asynchronous. You can compare the synchronous follower and asynchronous follower. Okay. Okay, after that, I'm going to talk about setting up new follower. Uh, what uh, important characteristic of distributed systems is scalability. In scalability, when the number of clients increase, okay, for support, supporting new clients and the new users. Okay, we need to increase the number of matches, the number of nodes in the distributed systems. Okay, so we need to setting up new followers. Uh, okay, we want to add the new matches and the new matching must have up-to-date information. Okay, so uh, uh, how we can setting up new followers is the question that we want to talk about to talk about it. We know that the data is in flux and high availability is important. Okay, so what is the solution? Uh, uh, we can a snapshot, take a snapshot of the leaders database at some point in time and copy it. Okay, we know take a snapshot is a heavy process, heavy load process. Okay, when it's possible, we need to take a snapshot of leaders database. Okay, and okay, when the new followers wants to uh, setting up this snapshot uh, this snapshot uh, can be used in the new followers. Okay, so the new followers at firstly the new followers the snapshot of the leaders database is copy to the new followers. And after a snapshot, after get a snapshot, the request change that process by leader uh, must be stored stored in the specific file to the log file. Okay, so in another sentence, I can say the request change after a snapshot, the request change that have happened since the snapshot was taken. This request change must be saved to a log file. Uh, okay, the follower uh, uh, at the time of setting up, uh, firstly use the snapshot of the leaders database, and after that it's should process the backlog of data change. Okay, I talk about the backlog of data change. I say you that all requests after the snapshot must be stored in a backlog. This backlog uh, must be processed by the followers. It's called cache up. It's called cache up. Okay, so what is the cache up? Is uh, the backlog of data change. Are this step sequentially or simultaneously? Sequentially, Mustafa. Firstly, firstly, uh, the snapshot of all leaders database is used to create uh, the original database. Okay, after that, uh, the backlog of data chain must be processed. Okay. Any other question? Okay. The This slide talk about the handling node outage. Node outage. Okay, because of the uh, link which are disconnected because of some matching that the matches which crash. Okay, the node outage can be occur for any systems, for any distributed systems. Okay, we need to handling node outage in the distributed systems. Excuse me, doctor, we are few. It's possible to include a second class in which the translation of the lecture is available. Uh, uh, Ibrahim, uh, I don't know. I cannot help you in this. I need a translator, but it's uh, I need translator, but it's up to you and your classmate. Uh, if anyone's is candidate for translation, okay, I appreciate to use translator in the class. But uh, I think there is not candidate a student for translation. I'm with Ibrahim, please actor. I say that it's possible to combine two classes together. Uh, Mustafa, I cannot combine these two classes, uh, unfortunately. But if you want, uh, I can send. I think I can send the link of the class, uh, the next class for you, and you can take parts in two class, this one and the next one. I think it can be possible. Can you please sit with another class? right, I say that it's not up to me, and I cannot get decision about these questions, these suggestions. Uh, okay, but I think that I must search for to find the the links, the link. Okay. Okay. Poor English and poor. This is the department has this issue. Uh, uh, is there anyone to understand the Farsi language? کسی فارسی هست که کسی هست که راحت no, okay, so okay, so the English language is the shared language between us. Okay, so I must talk in English. And Mustafa, can you translate to the Arabic for your classmate, Mustafa Karim? Or Muhammad Khatam, can you understand Farsi? Not good? Oh, okay. Ahmed Shahid, okay, can you understand Farsi, Ahmed Shahid? Or Muhammad Khatam, can you understand the Farsi language? If you can, okay, I can talk in Farsi, and okay, so you should to translate to the or Persian language is weaker than English. Oh, okay, okay, it's so bad for me. Okay, so only this is the only choice for us. Okay, I talk in English and yes, I think it's possible to download the translated lecture on the DARS website. Yes, I think it's possible. Also, you can uh, talk with other students in another class and get uh, the links of the next class or other other classes of this course, and or you can get the uh, files. Yes, I have the lectures. Ibrahim, okay, do you have the lectures? Uh, did you get the lectures from the students from other class? Okay, thank you, Ibrahim. Thank you, Ibrahim. I suggest you if you can uh, make a group. I think in WhatsApp, for example, and you can send this file in the group, and all the students can download the files. Uh, it's one choice, one solution for you. Uh, okay, I talk about the handling node outage. Okay, I say you uh, there are different events that can node outage. Okay, so we need to keep the system as a whole running despite individual node failures. Okay, it's possible that individual node failures, but we need to keep the system as a whole or as a whole running. Uh, okay, this node can be the follower or leader. Okay, so for follower failure, we can use a cache of recovery. I talked about the cache of recovery in the previous slide. Okay, when after repairing the the node outage, uh, after repairing the node, uh, Uh, the node must process the cache up, uh, the cache up. Uh, so the the node should to uh, use the snapshot of leaders database, and after that uh, it must process the backlog of data change. But this node can be the leader. Okay, the leader failure is it's called failover. It's very important because you know the uh, leader is different from the leaders because if the leader outage, okay, all write requests cannot process because we know that all write requests or update requests uh, should process by a leader. Okay, so it's called failover, and in this state, uh, the system uh, should promote one of the followers, promoting one of the followers to be the new leader, promoting one of the followers to be the leaders. Okay, so for example, uh, Oh, okay. We know that the leader is the leader has important role in distributed database. Okay, and in replication, when the leader fail, okay, we need to. Okay, so in this example, okay, the leader fail. Okay, so one of these follower must should select as the new leader. Okay, selecting one of these follower as a leader can be manually or automatically. The okay, so one of these should select as a leader. Um, and when the leader come back to the system and after repairing the previous leader, the leaders this leader the role of this leader changed as a follower. Okay, when the previous leader uh, come back, the role of this leader can be changed to the follower. Uh, okay, I'm going to talk about this method. One method for failover is the failover uh, can be performed automatically. In the automatic failover, uh, firstly, we must determine that the leader has failed. Okay, we must understand the system should understand that the leader has failed. Okay, okay. Which method can be used? Which method can be used for determining the leader has failed? Uh, one significant method is using timeout. When the followers, when the followers uh, don't uh, get don't get the latest information from the leaders, from the leader after some times, okay, they can determine that the leader has failed. Okay, so by using they can send some message to the leader, and if they don't the acknowledge message, okay, they can understand the leader has failed. Okay, so the followers should choose a new leader. One process that can be occur is election process. Election process or previously elected controller node. The election process one of followers uh, selected as a leader by election. By election. Uh, I know in the previous week you have election uh, in Iraq, and I know that. Okay, also the election can be used for this. for choosing this role. And after selecting uh, the new leader, the system should configure to use the new leaders. Okay, so the elected uh, the selected uh, uh, leader, the new leader, manage all requests, manage all right queries, and when uh, the previous leader come back to the systems after a failover. Uh, okay, the role of all leader uh, is a follower. Okay, it's clear for you? Are you understanding? Uh, it's up to the system and to the system manager, Mustafa. Usually, uh, uh, especially for the large system, we need to use the automatic failover, not manual. The manual method is a method that need specialists to check the network, to check the database in all time. Okay, so a manager, a special manager must find the fail and okay, after that this expert person, this expert engineer need to choose the new follower, the new leader. But uh, especially for the large system, with the for the system that have many nodes, many batches, okay, we need to use automatic failover. But there are some challenge with failover. If asynchronous model is used, what happened to the write not received to follower? This is one question. Uh, okay, we know that some followers uh, can be asynchronous follower. Okay, and we know that the data in asynchronous follower and leader can be different in some times, in some moments. We know that. Uh, okay, so uh, conflicting right. In the meantime, conflicting rights. In the meantime, it's one challenge with failover because uh, when the leader come back to the systems after fix after repairing, okay, it's possible that leader have the latest information that are not sent to the followers. Okay, so we need to discard conflicting rights. Uh, discard conflicting right. Okay, so this technique violates durability, violate durability. which is one important characteristics of database. Discarding write is dangerous if other storage systems outside of the database need to be coordinated with the database contents. Okay, this is one challenge with failover. Another challenge with failover is split brain. What is this challenge? Uh, uh, I'm going to talk about the scenario, one scenario for this challenge. Uh, uh, Please consider that we have one system in two countries. Okay, for example, we have one distributed system, distributed database in two countries. Uh, okay. Um, uh, I'm sorry. I need uh, uh, about 5 minutes because there is a problem. Okay. After that, inshallah, I will continue this concept. Please let me. Okay. We can have a break time for 5 minutes. After that, inshallah, I'm going to talk about this the challenge. I Okay. I came back to the class. Okay, I'm going to continue talking about the challenge with failover. One one challenge is a split brain. I'm going to talk about to describe a scenario for you. I say you that consider that we have a distributed database which are located into two countries, and okay, and the leader is located in one country. Okay, for example, we have a distributed database which are located into Iraq and Iran. And if the connection between the Iran and Iraq, okay, for some times, for example, cut off the connection between the Iran and Iraq, and for example, the leader is in Iraq, for example. Okay, so the followers which are located in the Iran uh, think that okay, find the problem. Okay, so they try to uh, choose another leader. Okay, so the followers which are located in Iran select the leader from themselves. Okay, so one of followers in Iran select as a leader. After some time, the connection between the Iraq and Iran uh, repair uh, and fix. Okay, so we know that at this time uh, there are two leaders because before repairing the connection between these two countries, uh, there is one leader in Iraq and one leader in Iran. Okay, so after repairing uh, this connection, okay, at the same time, there are two leaders, and we know that is not correct. It's called a split brain. It's called a split brain. Existence of two leaders at the same time. Okay, and we know that these two leaders both accept right. The leader in Iran accept rights that right request from the clients of Iran, and also the leader in Iraq, accepts all right requests from the clients of Iraq. Okay, so both accept right, and so what's happened? And this is a challenge. How we can use two different databases. Okay, as possible, some data lost or corrupted. Uh, okay, and another challenge with failover is appropriate timeout. You know, uh, the timeout mechanism, using the timeout mechanism is a way to determine that leader has failed. Okay, and uh, we need to determine the appropriate timeout for the system. Uh, okay, so determining this timeout is another challenge with failover because if we select the timeout short, if we use a short time for timeout, okay, so unnecessary failover uh, can be occur, and it's not good because this method is likely to make the situation worse, not better, because each failover each failover process is a heavy process, and also it can cause some loss or corrupted data or other challenge which can be occur according to choosing not appropriate timeout. Okay, any question? Welcome. Okay, and now I'm going to talk about replication logs implementation. I say you that all right that sent to the leader. Okay, in this figure, you know, each write to which is sent to the leader must be stored in the data change or replication log. And we know that this replication log should send to the all followers, and we know that this replication log also can be used uh, in set up new followers, because in cache of process we need to use this replication log. Okay, so uh, I'm going to talk about the replication log implementation. There are some methods for to implement replication logs. Uh, First of all is using a statement-based replication. A statement-based replication means that you know each write request, each write query is a statement, and okay, so one method is using statement-based replication. It means that all statements which are sent to the leader save to the log file, and in when it's needed, okay, we can use the uh, all statement. But the leader like every write request. Okay, it's called. I say it's called write request. It's a statement. The leader logs every write request and send it to the followers. But there are some challenge for using statements replication. One of them, some statement uh, some statements are deterministic functions. For example, no or rand. You know, these these functions uh, return different values when we perform them. For example, you know, the rand function return the random value. Okay, so uh, if any follower perform this function, okay, the value which are obtained from this function are different in followers, and we know we need to have the same value in all followers. Yeah, or another function is no. The no function return the daytime, the daytime, and it's a timestamp. Okay, the timestamp is different in any followers, because, for example, if the leader perform this statement now, okay, the follower perform this statement after some seconds or some times. Okay, and so this function return different values of in different matches, and we need consistency, and we cannot use these functions. Um, Also, another statement need to uh, execute our specific conditions, and also some statements such as trigger, such as some store procedure have side effect. Okay, so because of some reasons, because of these reasons, we cannot use this method statement based replication, because it can be cause inconsistency. Another method to implement replication logs is using write ahead log shipping, or WAL shipping. Write ahead log shipping, or WAL shipping. Every write is appended to a log as sent to followers, but in a specific format. Uh, write ahead log shipping use uh, the exact copy of data from the storage, and these uh, data uh, are stored to the log file and sent to the followers. But we know that this method is very low level, because a WAL contain details of which byte were changed in which this block. So this method can be used for some matches that are very similar to each other in architecture, in operating system, in all characteristics of systems. And so this method is closely coupled to the storage engine, and we cannot use this method for the distributed systems which are uh, distribute over some matches, different operating systems. Okay, so we cannot use these techniques to implement replication log. And finally, is a logical log replication. Uh, we know that in distributed system, we have some matches which can be different in architecture, in operating system, in other characteristics of systems. Okay, so it's better to use a logical log replication, a row-based log replication. Uh, okay, in this technique, we can use a different formats for replication and for the storage engine. Okay, each matching can use its own storage engine, and we want to use the replication log. You have to save the and provide the replication log in logical log, in logical format, and okay, this logical log, it can be processed by any machine with different types of uh, architecture and operating system and any other characteristics. Again, for example, we know that some queries which are usually uh, performed on a database are insert query, or delete query, and an update query. And we know that. Okay, for example, for an inserted row, okay, we want to insert the new row to the database. Okay, it's we need to perform insert query. The log, this logical log, uh, contains the new values of all columns. You know, in insert query, we should to determine the value for each column of the table. Okay, so the log uh, should contain the new values of all columns. Or for a deleted row, the log contain enough information to uniquely identify the row that was deleted. Okay, for example, the log can contain the primary key of table, the primary key. Okay, we need to only the log should contain enough information to uniquely identify the row that was selected. Uh, uh, Omar, okay, it's a problem. Omar, right, that today there is a problem with the sound and the picture interruption. Uh, uh, okay, I'm going to finish this lecture now. For after some minutes. Okay, let me to finish this slide. Inshallah, after that, uh, we can finish the class and continue in the next session. Inshallah. But I'm going to specify uh, the log replication and which information. Uh, yes. This is this slide or okay, for an updated row, and we want to update any row in the database. We know this updated information sent to the leader, and we need to implement the log file. Okay, the log for updated row contain enough information to uniquely identify the updated row. Okay, so first we need to uh, uh, have enough information to uniquely identify the updated row, and also we need to new values of all columns. The new value of all columns. Uh, okay, for example, in this example, you can see uh, an update query. An update query. The update query is sent from user to the leader, and the you can see the log, the replication log. You can see that this replication log consists of some information. For example, the name of tables, its users, the primary key. Okay, we know that by using the primary key, we can choose uh, uh, choose a specific row of table which wants to change the columns. Okay, and the columns specify the column that we want to change its data. The old value specify the old value of this column. Okay, the old value of this column is picture is of the column of picture URL is me-old.jpg, and also the new value for this column for picture URL is me-new.jpg. Okay, so these are the logical log. By using these information, we can uh, yes, by using this information, we can uh, uniquely identify the updated row and also the new values for all columns. Okay, in this example, for one column. Uh, and another method for replication logs implementation is using trigger-based replication. A trigger-based replication needs some information about the trigger. Trigger is a specific is a of a database. I don't know that you have any information about the trigger, but the trigger-based replication is more flexible in comparison with other methods because replicate a subset of data, replicate from one kind of database to another, and conflict resolution logic. Okay, that's enough for today. I know that's enough for today. If do you have any question? I'm hearing, but if you don't have any question, okay, I can finish the class now. Inshallah, I will continue this concept in the next session. Uh, any question? Any question? Thank you too. Have a good day. Uh, Thank you for participating. Mustafa, Umar, Zaid, and all the students, Muhammad, Zia, and have a good day and time. Bye for now. Inshallah, up to next week. You're welcome. Bye. خدا حافظ همه شما. خدا حافظ.